Hello everybody, welcome back. Today in this video we will discuss the estimation of fixed factors panel data model using Stata. Just for practical discussion, we are using panel data sets of 11 African countries, each observed annually from 1970 to 2023. Because we observe several countries over many years, that is, each country is observed for 54 years, that is from 1970 to 2023. We have both cross-sectional and time series dimensions in our dataset, what we call a panel data. Suppose, for example, we are examining the impacts of inflation and foreign direct investment on the economic growth of the African countries in the sample. Our basic growth model can be specified as follows. That is, the dependent variable is the natural logarithm of gross domestic products, where I is the country identifier and T is the time, or in our case, the year identifier, which is equal to beta naught, that is a model intercept, plus beta 1, that is the coefficient on the first independent variable, that is the natural logarithm of consumer price index, which is the proxy for inflation, plus beta 2 times the natural logarithm of the foreign direct investment. Here, beta 2 is the second slope parameter in our equation, which captures the effect of foreign direct investment on economic growth, plus mu I, which captures country fixed or country specific unobserved effects, and plus the last term, that is UIT, which is the random error term which varies across both country and time. Now, an important issue in panel data estimation is that countries actually differ in several ways that are not directly measurable. For example, African countries may differ in their institutional quality, in their geography, in their political condition, in their colonial background, in their culture, and their governance structure, and the resource endowments, and so on. These things are usually difficult to measure directly, but still they can affect economic growth. That is a dependent variable in our case. And also they may be correlated with inflation and the foreign direct investments. These are the two regressors in our equation. That leads to the issue of endogeneity. So the fixed effects model allows us to control for such unobserved country fixed characteristics when they are correlated with the independent variables that are actually measured and included in the model. That means the fixed effects estimator removes the influence of all time invariant country characteristics and focuses only on the changes occurring within each country. In our context, for example, we examine how do changes in inflation and foreign direct investment within a given African country affect its economic growth. So it is very clear that the intention here is not to compare one country with another one. Therefore, finally, our fixed effects model can be specified as follows. That is, the natural logarithm of gross domestic products is equal to alpha I. Here, the intercept is allowed to vary across countries in an attempt to control for the country heterogeneity, plus beta 1, that is the common slope, times the natural logarithm of consumer price index, plus beta 2 times the natural logarithm of foreign direct investment, plus UIT. So this is the model to be estimated using the actual data set. Now, let's proceed to the estimation of the panel data set using the fixed effect estimation approach. We have observed 11 African countries, each from 1970 to 2023. Therefore, the total number of observation on our data set is 11 times 54. That's about 594. These three-letter codes indicate the names of the country in short, and ID is any arbitrary number just assigned for the country because Stata cannot read those string variables. For example, the first country in our sample, that is Cote d'Ivoire, is assigned with the code of 11, and likewise the second country, that is Algeria, is assigned with 12. That's just any arbitrary code. And likewise, the third country in our sample, Egypt, is assigned with 13. That is just country code. And the fourth country in our sample, as you can see here, is Ethiopia. And Ethiopia is assigned with any arbitrary code, that is 14, and the like. So each country is observed for 54 years. And the dependent variable, as we have said before, is the natural logarithm of gross domestic product. So that's a proxy for economic growth. And the two independent variables are inflation and the foreign direct investment. And we have collected each of these three variables for each of the countries involved in the sample just from 1970 to 2023. So this is how to arrange the panel data structure in the Excel spreadsheet. So now, using this data, we are going to fit the fixed factors panel data model within Stata. Just before just we estimate the model, we first declare the panel structure of our dataset using the xt set. That is nothing but the command to declare the panel data structure of our dataset. X represents the cross-sectional observation and T indicates the time observation, okay? And as we have said earlier, the countries were captured by artificial codes. So the cross-sectional identifier in our case is the country ID that is arbitrarily determined. So xt set. Then first just choose the panel identifier, that is ID. And then the time identifier, in my case that is year. This is a time variable. Then enter. We have strongly balanced panel. That means the time series observation for each of the country in our sample is equal. That means there is no any missing observation for any of the countries in the sample. That's a good case. And the time variable, as you can see here, is a year, which runs from 1970 through 2023, and delta as 1 unit. That is a gap between two consecutive observations, and 1 unit. That's one, of course, obviously that's known. So now it is the time to run the fixed factors regression using this data set. So to do that, you need to type this command, that is xt reg reg. Then choose the dependent variable first, that is GDP, and then on the independent variables one by one. So the first independent variable is inflation, and the second independent variable is the foreign direct investments. After just providing this command, use comma and simply type this FE, that is to mean fixed effects. Then now run. As you can see here, we have generated these outputs through the fixed effects regression. Let's examine now these results one by one. The nature of the estimation is fixed effects within regression. That means we have estimated the model using within transformation by removing all time invariant country fixed effects. In other words, our estimation focuses on how changes in inflation and FDI, that is foreign direct investment, within each country over time affect GDP. And regarding the panel structure, we have the number of groups here. That's the number of groups is 11. That means the number of groups means that the number of cross-sectional units in the panel. Obviously, we have 11 African countries in our panel. The number of observations is 594, which is n times t, where n is the number of cross-sectional units, that is 11, times the time span, that is the time range. Each country is observed for 54 years, that is from 1970 to 2023. So the gap between 1970 and the 2023 is 54. So 54 times 11 is exactly 594. And another important component of these results is the coefficient of determination. Here, the most important coefficient of determination and fixed effects estimation is the within coefficient of determination, that is 0.8964, which implies that about 89.64% of the within country variation in GDP is explained by inflation and FDI, which is clearly a very high explanatory power. As we come to the coefficient estimators, the estimated coefficient corresponding to the inflation variable is, as you can see here, it's negative, that's negative 0.7534, and with its corresponding probability value of 0.000, which is much lower than the conventional 5% critical threshold for statistical significance. So the relationship between inflation and economic growth is negative, and that relationship is statistically significant, meaning that inflation imposes a negative and statistically significant effect on GDP. Holding FDI constant, a 1% increase in inflation leads to a decrease of about 0.75% in GDP within a country over time. Since the probability value is less than 0.05, as we have said before, this effect is statistically significant. And regarding the second regressor, that is FDI, the estimated coefficient is positive, that is 0.8167, which is closely 0.82. But unfortunately, its probability value is much higher than the critical 5% threshold for statistical significance, even though the foreign and direct investment makes a positive relationship with economic growth. That relationship is not statistically significant because the reported probability value, that is 0.434, is much higher than the conventional 5% critical threshold for statistical significance. As you can see here, the reported probability is 43%, which is much higher than 5%. Now let's see the statistical properties of our model, starting with the reported F statistic, that is 25.14. And the most important thing here is its reported probability value, which is 0.000, which is much lower than the critical 5%. So this suggests that the model is jointly statistically significant, meaning that inflation and FDI together significantly explain variations in GDP. So the regressors involved in our analysis are relevant. Still, another crucial component of the model results is the estimated coefficient for this row, that is 0.74, which represents country fixed factors. So the estimated coefficient for row, that is 0.746, implies that approximately 74.6% of the total variance in GDP is due to country specific factors. This strongly justifies our use of fixed factors analysis in the context of our datasets. And obviously, much of the variation, that is about 74% of the variation in GDP, is coming from country fixed factors. Therefore, our use of the fixed factors analysis is justified. Furthermore, the appropriateness of the fixed factors model in our context is also tested by the F test, that all of the country fixed factors are zero. That means the country fixed or individual factors are not significant. As you can see here, the F statistic corresponding to this test is 157.88, and its corresponding probability value is 0, which is much lower than the critical 5% threshold for the statistical significance. So this examines whether country-specific effects exist. Since this probability value is strongly significant, we can reject the null hypothesis that all country effects are zero, concluding that fixed effects estimation is suitable in our context. Thank you very much.